Good afternoon, everybody, and thank you for joining us. Our presentation this afternoon is about landscape technology and performance modeling. Chen Yu Lin and Jonathan Cape are going to tell us about some of their three-dimension modeling investigations and their applications to real-life research and design. These are the kind of concepts and design thinking criteria that they teach and explore in their parametric design course in the School of Landscape Architecture. Jay Cadwallader of BAC Makers is also one of our students, and he's going to show us how advanced 3D modeling techniques are applied to making, in particular to the making of artistic objects that will be placed in the natural landscape. But before we share on our speakers' presentations, I have a few introductory slides that I will introduce now. Please allow me to share my screen. And in talking about performance modeling, I want to bring up the idea of digital twins, which are very advanced 3D models that are becoming a widely used tool in many planning departments around the nation. And they are all interconnected through GIS and other database applications. And they allow us to be able to see and understand the built environment at multiple perspectives in an easy and seamless way to travel from one scale to the other. So you see here in the image one of those examples, how 3D models that can live in the cloud can allow us to understand a region, a city, and a building, and the building within the city and the region. These things have existed for a long time, but what is innovative is that with our new technology, we can actually capture reality in a way by capturing real images of places and projecting them into the model. To be able to really visualize and understand what things are happening, not only in a digital perspective, but also from a design perspective. We already have some of these examples, and here you can see the Boston Planning and Development Agency website, where there is an amazing 3D model of the entire city of Boston. And you can enter the model and immerse into it and move around and see the existing buildings and the proposed buildings. But imagine if to this technology we could also add real images, such as the ones that we get with Google Earth or with satellite imagery. So that's what GIS and other applications are working on, to try to combine reality capture, by that meaning these high definition visual renderings, with all sorts of data that are associated, incorporated into the GIS model and the GIS ecosystem. So the future is a vision, and this is taken from a lecture by Jack Dangermond, the president of ESRI, who introduced the idea or presented the idea how all these things are becoming more and more integrated. And we have now new tools The technology is developing all the time very quickly, and we can really manage big data in ways that can become usable for our individual planning and design purposes. And with this brief introduction, I would like to pass the mic to Chen-Yu. Please, Chen-Yu, feel free to share your screen whenever you're ready.
Okay, thank you, Margarita, for the introduction. Now let me share the screen. Okay, can everyone see my screen now? Okay, thank you. Cool. Hi, everyone. I'm Chen-Yu Lin. I'm a BAC alumni, and I'm currently a PhD student and graduate assistant at SUNY College of Environmental Science and Forestry. And I co-instruct parametric landscape with Jonathan at the BAC.
Hi there. As Chinyu said, my name is Jonathan Cave. We co-teach this course and have been exploring 3D modeling and data integration into 3D modeling in a research method through academia and then also through professional practice where I work at Halverson Taya Bond Studio. So in this presentation, we're going to look at two perspectives, one coming from academia research that Chinyu is going to talk about, and then me thinking about how I can take some of those ideas that he's cultivating, think about them for both our course, and then think about how they can be relevant to professional practice and what application methods we have for that.
So I'm going to start with the academic perspective and research collaboration with professions. In this section, I will present about data integration, digital simulation, possible software for different purposes, following by further interaction and conversation with feedback loops for technology adaptation. So and this perspective is basically based on my current academic experience and is in still maturing stage to be refined and understand. So in 21st century, we are immersed with abundant information, platform, and technology. We realize that it is inevitable to embrace the technology adaptation in our industry. Therefore, we may think about the mindset of technology adaptation in landscape architecture. We research and try new things, and here I have some phrases from a book called Codify, which I think are interesting to be shared. When we involve technology in landscape architecture, we will intentionally use tools for design thinking. Interesting phrases as concept in this book, the workflow comprised of database and computational simulation make us ready to be part of STEAM professions. We will be encouraged to become conscious of change over time and advocate for an embrace of new information sources and some instance of technology adaptation within different technology have already been discussed in the digital landscape architecture conference for a couple of years already. In the academic area I'm currently working on, we use big data translation and collaborate with relevant professions. Data visualization by computational simulation is required in this case. We also apply responsive 3D modeling for testing projects and deducing results as strategies or typologies. Interactive conversation and process are also significant for workflow generation and organization. So this is my master thesis project at the BAC before. It's about urban heat island, and I was applying algorithmic analysis and parametric design for approving possible strategies to ameliorate extreme temperature. When I was trying to continue this project, I aim to refine the workflow because I realized it is hard for other professions and audiences to comfortably interact and understand the circumstance, especially when we are presenting invisible phenomena at the very beginning. I was then back to the organization of common software used for different purposes in terms of workflow as vertical axis and data visualization as horizontal axis that's shown in this diagram. Usually we have 3D modeling and static diagrams present solid design concepts from algorithmic analysis and 3D modeling. However, what are possible opportunities having our data visualization more integrated, interactive, and understandable for conversation and collaboration? Given that consideration, the technology we bring for for this case of integrated data visualization could be virtual reality, that is also known as VR. Here we are back to a diagram with familiar software, and we can bring in VR technology by using software for game engine through transition with prevalent software and further additional plugins. In this case, I use Unity, collaborating with common options we know like ArcGIS, Adobe Series, AutoCAD, and Rhino, and plugins such as geographic imagery in Photoshop and C# through Visual Studio in Unity. So this is how I was working in Unity. The interface was totally different and it mainly focused on dynamic and interactive virtual environment. Although it is so different from 3D modeling software in landscape architecture and our familiar industry, I realized the potential translation between software to software majorly used in our industry to get engine for virtual reality. And this project is named as Thermal Impacts Observed by Snow Change. The process is potential to be part of workflow development for technology adaptation. For this project, I made a video to demonstrate the generative workflow among software transition. This video trails for Snow Change can help with further conversation as a proof of concept. It also guides audiences to another extra link to the game mode, that is the virtual environment, for experience and interaction with the Snow Change atmosphere to more understand the thermal impact. So at the beginning part of this video is showing the compiling workflow from 2D mapping information modeling in ArcGIS through AutoCAD and Rhino to 3D modeling, and then get into the game engine in Unity by manipulating the data base. And then the later part is showing how we can demonstrate the dynamic video and in the virtual environment. We also realized the flexibility to play with the data. And within that, for different purposes, we can demonstrate the value by organizing the database and also in the virtual environments for more understanding and more interaction. So besides my focus topic on thermal impacts observation, which generates further conversation and applications from my master thesis, other students working in the same group also have individual focus topics such as tree growing through data manipulation, from programming language RStudio to Blender, that is another 3D modeling. Another fantastic instance in our group is representative sulfur density change reflected to the atmosphere. Till here, from exemplar work process, we realize the difficulties and meanwhile excitement for exploring methodologies of visualizing time change and invisible characteristics. We work with environmental scientists and engineers for data translation and interaction interactive experience that are beneficial for technology adaptation and collaborative workflow development. When we are back to the diagram of software deployment, we can see the possibility of how to extend and connect software for a more comprehensive workflow in terms of purposes. In my case, or in this case, next steps for the thermal impact observation will be going back to my master thesis and continue refining algorithmic analysis and parametric design typologies based on data collection from audiences' feedback in VR that I created before in the video. And also another link to the game engine. In addition, documenting the workflow is critical and is regarded as one of missions we can take to follow the trend of technology. There are some common conditions we would encounter while researching. We mostly face challenges from issue-driven when we develop workflow due to different professions' participation. Usually, we spend most of time understanding purpose and needs. Communication among specialists is challenged and conducive for tasks assigned at specific roles. And because we usually start with inflexible scripts by diverse software, the collaboration and process among roles become essential. We appreciate having participation, collaboration, and important feedback from professional fields, especially in my study area, which majorly includes landscape architecture and other relevant industry. It will greatly help us to develop workflow reflecting practical project needs.
Thanks, Chenyu. So the next part I'm going to talk about is how we take some of the concepts that are developed by research, how Chenyu has pursued his research, and how us practicing landscape architects can teach that to our students and think about methodologies that they can use to integrate in a workflow that is common and might be appropriate for most office spaces. So as Chenyu said, there's a host of softwares that are commonly utilized by design firms. Each of these softwares has a purpose that is diverse. Some of them are more on the analysis side, some are more on the design side, some are more on the rendering and visualization side. And so as we develop the course and as I think about how data integration into modeling can be translated into a practical sphere, I really had to consider, or we had to consider what types of softwares we were going to use, and we really wanted to simplify the process if possible. So one that stood out to us is Rhinoceros coupled with Grasshopper, or a plugin for Rhinoceros that is a visual coding system. The reason being that Rhinoceros is ubiquitous software that is used in architecture, landscape architecture, and many other design fields, such as like jewelry design. And Grasshopper, because there's a lot of opportunity with the visual coding software to expand our opportunities in analysis and design. And this one is open source, so many people are developing tools that can be utilized by us as designers to extract more information from our models. So what is the main benefit that we see in this is that we create responsive workflows. We can take in a simple model and extract a lot of information from it by writing these visual scripts such as you see on the right. So what is a plain model on the left can become a very sophisticated model that gives us continuous feedback on our design and our strategy. So for instance, a script can turn a simple imported topography into one that gives us elevation data and one that begins telling a story of the landscape. We can pull heat maps, we can augment the data, we can write scripts in various ways to begin answering many questions that we may have all from one model. We can also articulate specific questions. So for instance, on the left-hand side, I want to think about ADA accessibility. So here I'm looking at slopes above and below 5%, taking that elevation data that you saw earlier and translated it for a targeted question. Or maybe I'm thinking about ways that water pools on site, and so I'm looking for areas that don't have the appropriate slope needed in order to drain water and create positive drainage to the areas we would like. So in this presentation, I'm going to walk through a demo concept. And here we're just going to look at the introduction of a pathway and then also a path and a lookout structure above to just show how these tools can be integrated. And though I'm going to be speaking conceptually in this, you can certainly continue refining your scripts to work at a much more sophisticated and detail if you wanted to go into, say, design development or even construction and documentation. It isn't only represented and useful at a conceptual level, though that will be the topic here. So already you can see by the path area that I was wanting to create that there was a challenge area where our previous analysis and the question we proposed of ADA accessibility shows that this area along here is not ADA accessible and is too steep. So there's going to have to be some modifications there to get that to become ADA accessible. So opportunities are created with the software to write customized scripts with varying specificity, with varying target, so that in this case, I wanted to look at specific elevations between what I use as like 2 points. So instead of continuously calculating slope, I could just modify these 2 points and find the slope that is averaged between them. From there, you can write scripts that allow you to distribute contours based on a desired slope. So in this case, between those 2 points, when it was too great for ADA accessibility, I was like, okay, what happens if I bring it down to less than 5% and evenly distribute those contours? So you can begin seeing how those points with the slider that allows me to specify what type of slope I target evenly distributes it. So then I can modify my contours, as you see on the left-hand side, redraw them, and then instantly those contours are fed into a new model so that a new mesh is created. This takes out a lot of steps of having to continuously rebuild your meshes, continuously add to the model, and creates a loop so that when I update a contour, automatically the mesh updates, and then I could feed it back into my analysis. One thing that's important though, and to note, is that as you create these scripts, there are always constraints on the script. So you can see here that though I targeted that area that had too great of ADA or too great of a slope and brought it down, that because of the method I was using, you can see that it doesn't articulate a continuous width along that path. And that's just something that you have to note and see as a constraint. In this case, because it is just conceptual, it is something that we could go back to and hone through refining the script or simply moving out of it and into a more analog process. Opportunities are also created to look at water flow. So grading can be something that is three-dimensional, where no longer do we have to continuously analyze grades through 2D and CAD, but we can begin working three-dimensionally, modifying the contours, and then rebuilding the surfaces, and then getting a feedback of water flow direction to understand if water is going to be flowing into the basins that we want, if it's still going to be stagnated in some areas. And there are a number of ways to do that. So in this case, you can see these faint lines appearing in this continuous loop of water flow. So before with water flow directional diagram, that helps us understand that the way that water will flow at the starting point, but doesn't show us how it will change through the landscape. So opportunities to write scripts that are dynamic, that can create this loop of feedback so that you can see how the water itself is going to move and to navigate through our landscape, create opportunities to understand the hydrology of the site a lot more sophisticatedly than on a 2D plan. Looking at a lookout structure, in this case, we're looking at more of a design element rather than just terrain shaping. We have created a script that works on a base of set 4 points. Those 4 points are then added to a rather lengthy script based on parameters, and that can create a whole structure that is modifiable. So in this case, you can see that those 4 points then translate to the structure above, where we have this pathway that slopes up at a defined slope that we wanted. And then in the middle, we have defined a lookout point. So from that, we have a walkway that has a defined width to it. It has a defined length. There is handrails, and there is a structure underneath that we have begun applying shape to, and we begin constructing an element that can have some more formal gestures and can also adapt to changes based on our needed preferences. So from there, we can develop conceptually the base even further and begin to, from the design side, begin to utilize some of the power of Grasshopper and this algorithmic design and our rule-based formal explorations. So what does that mean? That means here, conceptually, you can look at this base where I have taken kind of this wood box, and I have scaled it, I have twisted it, and distorted based on a rule that was created within the script. And because the rule is following a certain mathematical process, the distortions are regular and are scaled appropriately, something that would be very difficult and very time consuming in an analog way, where individually, one by one, you would have to go through and affect each box. So there is a time-saving element to this, as well as a precision to this if you know what type of script you're wanting to write. So as I was saying, the time-saving element and the ability to adjust is really important with this. So in this instance, I have kind of a lookout pointing one direction and of one width, with a slope of on the walkway of a certain percentage. And by simply manipulating those initial 4 points, we can change all that, and something that would have taken hours to rebuild then becomes a 20-second computation by the computer. So this gives us a lot of opportunity to save time, to expand our design possibilities with parameters that are interconnected and dependent on one another. things that would be challenging if we were doing it in an analog way. But this process also comes with a lot of challenges that I am discovering, that I am trying to accommodate for, and trying to understand how it affects my work with colleagues, as well as how Chinyu and I teach in our class. So some of the points that are very challenging with this is that it's hard to work with existing workflows. This could be with your colleagues or just other methods that you have yourself for design exploration, or software interoperability can be challenging. It is also a very confusing process for someone who doesn't know how to script through Grasshopper. So looking at the scripts can be opaque, and if you build it the wrong way, they can be very inflexible, and you can find yourself with a very large time sink into something that you thought was going to pan out, but did not. So knowing that, how do we begin integrating this process into something that is appropriate for our practice? One method I would begin saying is, don't start big, start smaller. And I employ this all the time when I try to model. So what do I mean by that is, instead of having the whole model interrelated, is begin thinking about certain ways that you can chunk this up. So for instance, paving is something that can stand independent of the whole overall design idea. So that provides an opportunity to explore how paving strategies can be manipulated without affecting the larger design, and thinking about all the complexity that would entail. So on the left-hand side, you can see that there's an attractor either from the central structure or from the edge that changes the density of the light and dark pavers and the gradient in between. Or you can think about like furnishing design, or a singular element within the landscape where you may be employing a script to understand the radius and the gaps between slats, or the size of slats that you need, and be able to iterate quickly without having to rebuild each time. These are instances of how to begin tackling this at a smaller scale, while we still try to understand how we can build larger models that begin integrating all the elements so that they can adjust comprehensively. So thank you for listening. It is exciting to think about how we can take research, we can take data, and begin integrating it into the models, so that we have more opportunities to understand how our design is going to affect the landscape, and to build more sophisticatedly. So I'm going to turn the presentation over now to Jay, who's going to take it away.
I'm going to share my screen. Okay, do we have a PDF right now? You guys seeing that? All right, cool.
Yes, we do.
All right, so first of all, thank you for inviting me to collaborate with you guys. Your presentations are inspiring. Everybody today has been great, so I'm appreciative to be here. I'm here to talk on behalf of BAC makers, who I've been directing for 3 years, but whose work's been integral to the school for quite some time on and off, and who mentored me when I first got to Boston In this incarnation of the group, we are a fabrication and technology group. We are a research fabrication group. We are serious about play and research at the same time. And we found great success with that, creating works that are interactive. It's bent itself towards art that you can get into, but it started from a fascination with Jonathan Crary's techniques of the observer and was intended to only be a 4-week workshop. And there was such insight and inquiry from the group that showed up that together we've been working on a number of things. So this is just the first 8 workshop posters from the first year we were together. And some of the things that we worked on and in the early stages. And from the get-go, we've really put a contemporary lens on these crude technologies. The optics of the 19th century that we were so fond of were improved and created without variable because of the precision and time saving that Jonathan's presentation reminded me of in our own work. The ability to use fabrication tools and our incredible tolerances and precisions in drafting programs like CAD and modeling programs like Rhino to laser cut apertures and cut files for things we're putting together so that we know the focal length. Suddenly we're making cameras that inspired us better than the inventors ever could have, and trying to do justice to the work every time that we approach a new project in that way. And so when we started to do blueprinting through cyanotype, and the old process used the UV from the sun, one variable we fell victim to was cloud coverage and how fickle it can be just 10 minutes apart from between one rendering and another of a blueprint. And so while it was very beautiful, it does get to be wasteful when one batch turns out great and another batch of canvas just has to be tossed. And that became something we tried to troubleshoot. Using Rhino, we could use our laser dimensioning tools, figure out spaces and build to them. We started creating cameras now in the same fashion as that cardboard box that were inhabitable to participants. So they were walking into camera obscuras, and then we tried to jam it full of as many experiences as we had researched with all those workshop posters I showed you. And so there was a gallery of our work of 3D cameras, pinhole cameras. There was a footprint of a skylight that we brought down to the floor, and all of this was possible because of the modeling savvy that exists in the world today, these contemporary technologies that make what we do so much easier as artists. Still, we go back to, paper and wheat paste when it's appropriate. The neighborhood in Somerville, who hosted us for our first large-scale installation, has this culture of that. And so we tried to blend in, assume their role. That you see here, a projection surface for our camera obscura. All of that was able to be modeled. We knew the cut files because we drew them in AutoCAD. More precision, though, came in the form of the table that would become our new cyanotype development tank. The variable is now gone. We have CNC table so that we know the focal length, the depth of the table, the strength of the UV lights. And once one test strip has come out satisfactorily, we know exactly how long we need to develop every single picture from that point forward. That has been our approach, as I said, since our great success with the first cameras that we built, adapting contemporary and emerging technologies into what we do to do justice to those that inspired us. So that brings us to the Terrascope, which was really completed yesterday afternoon. And the Eels Preserve in Southborough, Massachusetts, commissioned initially alumnus Christian Borger and myself on the basis of this proposal. that I'm cycling through now. Our task was to create artwork that responded to the site and to the challenge of mending and healing in the difficult year we found ourselves in. And our concept was to create a serpentined periscope. It has high back chairs that eliminate would-be sight lines between the participants, so they're sat face to face with their backs to one another. It spans a fork in a trail so as to bring people of different walks to one another so they can see eye to eye. At 27 feet, it is now the longest existing periscope in the United States, and it works. We were capable of iterating and testing the variable of the magnification of our mirrors with great precision because of CNC technologies, once again, because of the ability to model and be very precise with our cut sheets, to be very precise with the mounting brackets and corners that we wanted to take, and to pretty much pre-flight the angles of the mirrors before we got onto the trail to eliminate as much variable as possible in the program and the software and in the fabrication process. Once they awarded that, we began making shop sets with the BAC makers, enlisted the crew once more. It's been a popular event to take part in these installations. I think it's what we all like to do the most, and it's been to a sort of gateway type parallel where practice hours are on the line for a lot of the participants, which is great. Also creates a lot of learning moments, times when there is variable in the way that people approach drawing details, and standards are talked about, and we have conversations about how we can create those standards so that these drawing sets can be understandable when it's time to fabricate. Thankfully, the same people who drew them or the people that were making them, we had a pretty good grasp of what was going on. It was fairly over-the-top approach to making sure we knew exactly how many parts we had when we got on the trail. And all of the fabrication that could be done prior to being on site was done. And so we loaded the back of a U-Haul on Saturday this weekend, drove out to Southborough in 2 other cars, and a great number of us BAC alumni and students, including people who flew from all over the nation to participate, came on site. We were ferried in by a couple trucks with higher suspension than my little SUV, and we were left to our devices. And so here you see the calm before the storm. We're sort of getting a bearing. You can see Christian at the very furthest point from the camera here with a tape measure in his hand, and he's trying to gather himself again as to how we should situate the length of the periscope. We know it's 27 feet. We don't so much remember or know how we'd like to place it in the site. And that's something I'd like to talk about towards the end of this presentation, something that going forward, some of the technologies we have access to now could even streamline and prevent that variable in our work. Once he'd measured, though, and we had a sense of it, part of the team used the short ends of the periscopes as sawhorse and began assembling the chairs. Part of the team spanned the long parts of the periscope across the decided route so that we knew where to put the chairs, and then begin fabricating or piecing together the rest of the prefabbed materials. Again, all these offcuts, they become tools to us on the trail. Those are happy accidents, and you need those just as often as you need the incredible planning, the emerging technology. You need some luck, and you need to do it the way they've always done it sometimes. Once this was fairly sturdy together, we had about 7 people, just with a prayer and some muscle, get it over into the site. And then 6 people held it, and 1 person grabbed the legs, which had been templated with 2 CNC cut holes that piloted where the legs needed to be, so they would always be a typical 8 inches apart, and really grab the sides of this periscope so that we could just impact and screw down right into the side, and then put a spanning joist that was cut to typical in between the studs. This is a really telling picture because one of the ratchet straps that would eventually hold the speaking device can be seen underneath as a last-ditch support to try to keep this thing as straight as possible and as level as possible. We have a level to the far left saying, okay, it seems good right now. We have a ratchet strap in the middle, and everyone's attention has diverted to the other end where the plumb line is giving us fits. So like I said, occasionally you got to be able to have both the technology and the prowess to roll with the punches in your toolkit, and that's what Makers has really tried to instill. You'll also see Quikrete over to the left here, and we casted in between each of the legs, then began sawing them down to size to adjust for the topo change, stained it red, put a talking tube on top, ratcheted it down, and let it be. I then took a mobile LiDAR device, walked the site, and got about as clear a read of the topography and the new installation as possible in 10 minutes that is possible. Professionally now I use LiDAR, and oftentimes it's on a tripod and spinning for 2 minutes to get quality data. It was phenomenal to walk at a 1 Mississippi pace through the woods where it's pretty wide open and still get such quality data. You can see it's points per million in this cloud. No matter how far down you scroll, that's a 3D object that also has setups at each of those red points that have very high definition 3D photographs, so that you compare this and register it to site. And you can slice what you need to, which would make understanding the topography before we'd moved in quite easy if we had done this prior to the project, and would have permitted for us to even prefabricate the legs to a certain height and run a plumb line inside of a model. And I will only just show you a 30-second video of how that works inside of the program. And then I'll be ready for questions. So this is just a registration program. It's like a pre-flight panel. There's many like it. As I move the slicing location up at the thickness that I've cut it, as you would in Revit or any other modeling software, it just drags that section of all those point cloud points with it. And it, I think in the future this could do a lot for us to analyze the integrity of interesting natural elements like tree forks and the like in future installations, to lean even further into more natural elements.
Thank you very much, Jay, and everyone else. There is a question on the chat from Kathleen Fritz. She asks if there are grasshopper templates that can be used as a foundation for modeling in Rhino.
I would say that there are a lot of resources that are available online. Many people are sharing, and there's a very large community that you can turn to. The strategy here is really creating the right questions so that you can find those resources. And as we have taught this class, we've been trying to gather more and more that we can use and give to students so that they can have foundational knowledge, so they have resources that they can turn to when troubleshooting arises and is needed. And then so you can also look at courses online or YouTube videos. Much of what I have learned has been found on forums and videos through strategic question searching.
Thank you. I would like to invite everybody to please post questions to the chat. And while you do that, I have a couple of questions of my own. And I'll start with Jonathan, since you were just speaking. Could you tell us a little bit about how do you personally approach the process of designing a script? How do you really get into these complex iterations? Where do you start?
Yeah, so I think first steps are independent of jumping into the program. Typically, I'll be, if it's academic or versus professional, I'll be thinking about what are the goals that are needing to be achieved. So this could be either design guidelines that have been given to me, or conversations with, say, principals or senior associates that might give me a guidance on like what types of things I need to be exploring. And then I'll take those and I usually write out or draw out kind of a direction set, almost like cooking instructions, where I like visually chunk out everything and think about what I'm going to have to build within the script. Because I said one of the challenges is that you can sink a lot of time in building the wrong thing. And I've done that many times. So I'm getting better about understanding how to construct a script that is more targeted and also has some variability in it so that it can adapt. But I think that the first step is definitely kind of storyboarding your goals and understanding how each of those are going to be written independently.
Thank you. Another quick question from Professor Fritz. Is there a forum you recommend?
There's definitely Grasshopper forums. I'll put a couple links. McNeil hosts a forum, and a lot of it has been a lot of Grasshopper discussions have been hosted on McNeil's own Rhino forums. So I think that's a great starting spot to ask your questions. And then beyond that, I think that there are resources hosted that there have been some booklets and that have been created that are open source. And I can also put a link to those that you can download for kind of explanatory modeling techniques and the basics to Grasshopper.
Thank you. There is also a question for Jay. Jay, what is the LiDAR tool and software you used in the wild?
So oftentimes I'll use a tripod and recap with an RTC 360. And for less money, actually, this is going to make you look like you're hunting for ghosts. oftentimes, and people will comment on it and get into your data and your shot oftentimes, but it does so many passes that it eliminates non-static elements of the cloud point data it gets. It's like a BLK to go, and I don't need to use a recap software. It tethers to my phone so that I can see the data that I'm getting. I can turn the density up and down to look at that, and I can turn a slicer up and down to section it even while I'm running the scan. It's one continuous walk at a fairly slow pace and then upload it and you're done. So I upload that to Register 360, but BLK to go is the LiDAR tool.
Thank you. And since we are getting close to the end of our session, I have one more question for Chenyu. Chenyu, you did all this wonderful study and analysis of the amount of snow that falls on a particular site during a period of a few years. What is the next element that you're going to study and record and analyze?
So from there, I was aimed to actually refine the workflow for my master project that was playing with the algorithmic data manipulation in Grasshopper. Why I get step back and get into Unity doing the game engine for virtual environment is trying to explain at the really beginning of the thermal impact phenomenon with the audience and my colleague. And from that stage that I realized it is really important to generate those kind of interaction and conversation with others to bring all together at the same page to start with the collaboration. So my next step from there would be like myself get back into the Grasshopper from the feedback of the virtual environment that we get that we generate, and could also I think the refinement of the virtual environment will be another steps as well for technology adaptation, and see what kind of purposes that we will create, because we found out there's a lot of flexibility, not only the software itself, but also the translation and transition between or among those. So that kind of workflow is pretty important to be organized as well. And that's what our next step will be that we are going to work on.
Thank you very much, everybody, for a great session. And thank you to our audience. And you can always follow us and keep adding questions on the chat if you want. We will make sure we respond. Thank you.